Okay, in this video, I'm going to go over the product rule, and I'm going to do that by talking about the first problem in the 3.1 homework. Okay, well, first off, let's talk about the product rule. If you have, say you have a function, so we'll call it h of x, and say that function is composed of f of x times g of x. So you're seeing right away that your function h of x has two functions as part of its composition. So if you want to take the derivative, what you're going to do is you're going to say left, which is the f of x, d right, g prime x. Now remember, when you do g prime of x, if you have chain rule, if you have power rule in play, you've got to be careful and make sure that you're considering that as well. So I've done so far left d right plus right d left. Okay, so since addition is commutative, you could do it in the other order. However, I really like the left and then the derivative of the right plus the right times the derivative of the left. So we'll say left derivative. Okay, that's what I really like. So I'm going to erase this and call this just L, just to be consistent. So left d right plus right d left. And these terms are multiplied. Okay, so given that, let's now work on the first problem so we can apply what we just talked about. So h of x equals, and this is number 1, 6x times x squared plus 5 squared. Okay, h prime of x equals left d right. So be careful here. Bring down the 2, that's the power rule, x squared plus 5 to the first, and then don't forget the chain rule. Okay, so we've done left d right plus right, which is x squared plus 5 squared, d left, which is 6. Okay, so let's clean this up a little bit. So right now I have a 6x. I think I'm going to maybe leave this in parens, but I'm going to bring the 2 and the 2x together. And then I have x squared plus 5. And then I have plus, I'm just going to bring the 6 in front, x squared plus 5 squared. Okay, so I am going to combine this. I'm going to go one more step. 6x times the 4x gives me 24x squared times x squared plus 5. And then plus 6 times x squared plus 5 squared. Okay, remember you're not done until you have simplified. So at this point, what we want to do is do some factoring. So I can see that 24x squared and 6 have 6 in common. Pull out the 6. Then I can see that they both have an x squared plus 5, and the greatest power they have in common is just the power of 1. So this is greatest common factoring, so I use my box. Okay, to get back this first term right here, what do I need? It looks like I'm just going to need a 4x squared. Okay, plus. Now to get back this term right here, all I need is 1 power of x squared plus 5. Okay, so then next step, 6x squared plus 5. Take your terms in the bracket and combine them. So I have 5x squared plus 5. Now look what I can still do. I can factor out a 5 from back here, and that's going to give me 30 here, x squared plus 5, and this will be x squared plus 1. So this is probably in the best form for you to work with. Because what if I said find the critical values? Well, you would just set both of the factors equal to 0 and solve. So this is the best form of the problem that you have done the product rule with. Okay, so on the next page of this video, what we'll do is one of the quotient rule problems. So let's do that next. Okay, so let's quickly review the quotient rule. So if you have a quotient, which is a fraction, and you want to take that derivative, we say the following. H prime of x equals low, which is the bottom, d high minus high d low all over low squared. Okay, so what did I do? I did low d high minus high d low over low squared. All right, so that's our rule of thumb. Now let's apply this to the first quotient problem in the 3.1 homework. So this is problem number 5. So I have that h of x equals 3x minus 2 cubed over 7x plus 5, and that quantity is taken to the fourth. Okay, so let's go ahead and do our derivative. Hopefully I have enough room. So h prime of x equals low 7x plus 5 to the fourth d high. Okay, bring down your power, 3x minus 2, that's going to be to the squared, and then times the derivative of the inside, because remember you have the chain rule. So far I've done low d high minus high 3x minus 2 cubed d low. So that's bring the 4 down, 7x plus 5 is now raised to the 3, and then times the 7 inside. And then your denominator is going to be squared. Since it's raised to the fourth already, squaring that raises it to the eighth. Okay, so I'm going to change my color. Now, look at what we have. I see the highest power I have in common of 7x plus 5 is in 3 places. So the rule of 3 lets me do the following. Get rid of this third power, so that's gone. Take a third power out of here, so this is going to be to the first power now, and then subtract 3 from here, and that's to the fifth. So that should get you started. Now, why don't we look at my numerator and try to clean up there a little bit as we go. So I'm going to go back to my blue color. Okay, so let's see if I can fit this in. So what I'm going to do now is I see that in the numerator only, I have 3x minus 2 squared in common to both terms. So I'm going to factor out a 3x minus 2, and that's going to be squared because that's the highest power. So then what do I need still? I need 3 times 3 is 9, so 9 times 7x plus 5, and then minus, I need another one of those powers, and I need 28. So here's a 28, and then I have 3x minus 2. Okay, and now all of this is still over 7x plus 5 to the fifth. Okay, the terms that are in the brackets, we're going to clean up. So what I'm going to do is I'm going to distribute the 9 inside to the 7x and the 5, and then distribute the 28 to the 3 and the 2. So let me do that and clean things up, and I'll give you the final answer. Okay, so what I'm going to tell you is when I worked in here, what I initially got was this. This was 63x plus 45 minus 84x plus 56. All right, that's what I got when I worked inside my bracket. So remember, when you do this negative times this negative, that's how I got the plus 56. All right, so then when I combine like terms, which I'm going to leave for you to do, I'm getting the following for my final answer. And it's much nicer than what this looks like. So negative 21x plus 101. And then this entire thing, right, is divided by 7x plus 5 raised to the 5th. And that is in the best form I could do. Okay? So that gives you a little review on both the product rule and the quotient rule. As long as I'm here, I'm going to do one more page on the rate of change. So let's do that next. So this was the only new thing that was in Chapter 3. And this is the rate of change. And so what they're doing is they're saying, let's just say that we'll do a triangle. So you have a triangle. Maybe I'll just do the first problem. So for question 9, they say the area of a triangle is determined by the formula area equals 1/2 base times height. But now everything is a function of time because things are changing. It's not just your regular triangle that is static. It's a dynamic situation. So the question goes on to say, at what rate is the area of the triangle changing? So they want to know what is A prime, given that the base of the triangle is 6, the height of the triangle is 10, the rate of change of the base, B prime, is 2 inches per second, and these are all inches, right? And that is a 10. That looks terrible, 10. Let me just make this 10 better. That's better. And then, let's see, and the rate of change of the height is negative 2 inches. So height prime equals negative 2 inches per second. Okay, so you have to do the product rule because your base and your height are both functions. So think of them as being f of x and g of x. Okay, so in order to get this, a prime of t, bring the half out. It's going to make your life so much easier. Then do the product rule. So the product rule tells me I'm going to do left, d right, plus right, d left. And look how I have all the numbers I can plug in. So what does that mean? Well, my base was 6, so this is 6. My h prime is a negative 2, plus my h was 10, and my b prime was a positive 2. So in the bracket, what do I have? I have a negative 12 plus a 20. So that is going to be an 8, and I want to have 1/2 of that. So 1/2 of 8 is 4, and it's going to be inches squared because area is squared, and you have the time component per second. That's the rate at which this area of the triangle is changing. Okay, so the only thing new was that we're viewing what normally would be a static triangle with an area of 1/2 base times height, and now it's a changing triangle. So they want to know, given the change that they've identified in the base and the height, how has the area been impacted? That's what they're asking you. Okay, so if your shape is a rectangle, you're using area equals base times height, and you'll be doing the exact same thing. So hopefully this will help get you started on this section.